As of today, Earth is home to more than 7.1 billion people, with 2 to 3 people being born every second. Unfortunately, however, the strain this large population has placed on the planet is quickly becoming more than it can sustain, as evident in current phenomena such as global warming. So what's the solution? Well, many scientists at NASA and other space organizations across the globe believe deep space exploration to discover another Earth-like planet is the key to the future of the human race. However, with our nearest planetary companion at an average of 225 million kilometers away, we will need new, innovative technologies to carry us at high speeds through the galaxy in search of a new home. One such device capable of traveling across immense distances at extreme speeds is the solar cell.
This solar sail will propel a small satellite through space later this summer. NASA will attempt to deploy and operate the spacecraft in low-orbit Earth propelled only by the power of sunlight. The ultra-thin 100-square-foot sail uses sunlight the same way a boat uses wind. The technology requires intercepting the constantly streaming solar energy, called photons, with giant reflective sails of lightweight material. The continuous pressure of the sun's light provides sufficient thrust for a small spacecraft to travel in space and alter its orbit.
The attractiveness of the solar cell lies in the fact that its fuel is free and never in short supply. After deployment in space, the lightweight metal cell is bombarded by photons from the sun, small particles of light who, although have no mass, can exert small amounts of pressure on an object. Since these particles are constantly streaming from the sun, the cell never runs low on fuel. The pressure exerted from the photons onto the cell generates thrust that then propels the spacecraft through space.
We have a radiation pressure and then we have solar wind. What we're going to use is the radiation pressure. This is a phenomenon in which a photon, which is massless but still has momentum, reacts with the surface and then bounces back off. It creates a very tiny pressure, but it is a pressure nonetheless, and once we're in the weightlessness of space, any pressure will turn into a force, and F equals ma, we'll get a small acceleration. Solar sails have been used before and they've flown before. The solar sails that have flown before have only been to demonstrate the concept of solar thrust and solar propulsion. But what we're aiming to do is take that in the next step and go into navigation and actually fly to someplace useful that only a solar sail can do. So what we're targeting for this program is a solar sail with an area of roughly 1,200 square meters. So we're in the neighborhood of about a quarter of a football field, if you will. With that, we'll create roughly 1 gram of thrust.
Already, these technologies are being developed to aid us in exploring the great void beyond Earth. In Japan, the Uchinoura Space Center launched a solar cell which successfully demonstrated orbiting and deep space flight capabilities. As researchers continue to work tirelessly on solar cell design, a constant issue in construction is the mass of the cell's mold, which must remain lightweight in order to be propelled by the pressure of the bombarding photons. As for the cell itself, the Japan Aerospace Exploration Agency's Institute of Space and Astronautical Sciences solar cell was constructed with a 0.5 micrometer thin film. Other agencies such as NASA have also experimented with lightweight foils and reflective plastics in an effort to construct the lightest cell possible. As our planet continues to grow increasingly crowded and is drained of its natural resources, we must continue to explore opportunities for resources and habitation. Just as European explorers looked out at the horizon from the mast of their sailing ships hundreds of years ago, we may someday soon sail again to bold, exciting worlds beyond our own. Only this time, instead of the wind, the power at our backs will come from the sun.